Right, we good? Awesome. So I can now get rid of this. For those of you who were wondering, I'm a local historian for Concert. That's why there's so many old industrial photos on there. Right. Okay. So just as a quick show of hands, how many of you used Postgres already? A few more than I would have thought, to be fair. Okay, so in case the slide hasn't given it away, that's what we're going to be talking about tonight. What I'm not going to cover is I'm not going to go through installing Postgres, I'm not going to go through setting it up, I'm not going to go through the different bits and pieces or anything to do with Entity Framework. I'm assuming as .NET developers we all know how to use Entity Framework and how that works in general. I'm going to go through a little bit of a use case. I'm going to introduce the official database driver for .NET, NPG-SQL, Dapper, because as you'll see from this, I really don't like framework anyway. I find it too heavyweight a lot of the time, and things like Dapper and using the ADO.NET interface directly tends to be where I tend to do a lot of my database code. Standard data types, although that's fairly simple stuff, I might actually skip over that. Some of the more advanced data types, and this is going to make you laugh, I've actually got the pub sub demo working this time. So we'll have that, and assuming I don't get kicked off, be all good. I don't think I need to say too much about who I am. I'm Peter Shaw, Shorty. Most of the people know me as either Shorty or Shorty DS. I've been doing this for far too long now. IT, electronics, computing, destroying things, building things. If you want to know more, you can actually watch Kasim's latest podcast thing that he's done. My episode, I think, was released tomorrow, Kasim? Yep. So you'll find out everything you want to know about me if you watch that. I've been doing this for about 40 years now. If you've been around .NET for any length of time, you may have come across a user group called Lidnug, an international one which I help run. I'm the UK guy behind it. It's nothing what it used to be. We used to do regular live sessions, that kind of stuff. But we are still there on the LinkedIn platform if you want to come and find us. Please do note, I am deaf. I wear these things in each ear. So if I'm not looking at you when you try to speak to me, and the further away you are, there's a very good chance I'll not really be able to make out what you're saying. So if you do have questions, you can leave them till the end. If it's really, really burning you and your pants are on fire, you jump up and down and wave your arms around like a lunatic till I notice you, and we'll take a question that way. Okay, so why Postgres? Postgres has got a very, very long history. I'm not going to bore you with all the details, but if you are familiar with the Syncfusion Succinctly ebook series, there is a free ebook available on Postgres that I wrote a number of years ago now that goes into the history as well. Some of the minor historical highlights, however, just points of interest. In some ways, Postgres is the great-great-grandfather of MS SQL, because in a very, very roundabout way, Postgres started its life, like a lot of these products, way back in UC Berkeley in the 60s and the 70s and whatnot. And that became, I forget the name of it, that became a database that was then acquired by IBM, which then went on to be part of the IBM DB2 family of products, which Microsoft then subsequently bought the IP and the technology rights to, which was then used to develop SQL Server. And between that time and SQL Server being released, Postgres as a whole was put back into open source, and it became Postgres from that point onwards. Postgres has never touted or marketed itself just as a database. In fact, if you ask any of the developers on the Postgres platform, and I've done a small amount of development work over the years as well as part of the open source project, they will tell you that it's a data application platform. And when you start digging into it, you begin to understand that very, very quickly, because it is more than just collections of tables and stored procedures like most databases are. This very much is a platform that you can add an insane amount of plugins to. I mean, if you can think of something that you would like to try and make your database do, then there is probably a plugin on the Postgres extension network that will do it for you. Somebody was talking to before mentioned the vector one. I think it was you, yeah. So vector, for example, with all this AI stuff that's coming out these days, there's been an extension for doing vector classes for quite a few years now. That has now been extended because AI is becoming so popular. The vector extension's been built into the core product. So you now have vector extensions, parallel execution, and goodness knows what other goodness that will run on GPUs, it'll run on CPUs, it'll run on all manner of things built directly in to the database. And I'm not just saying that we've got an extension either, we've got first-class data types for it. You'll see shortly that data types in Postgres are just a continuously blurry line. Stored procedures, we've all done stored procedures in SQL Server. Most people know what the purpose of them are. What if I told you that you could actually write your stored procedures in JavaScript, C#, C++, Go, Rust, Modular 2, Fortran, and just about any language you choose? If somebody has wanted to use a language for writing stored procedures in Postgres, there is an extension to do it. And it's just crazy. Good friend of mine who was working for a sports site, he had some data to process that was in JSON format, and he had to pre-process it before he fed it into the database. And he came to me and he said, well, Shorty, how can I do this? What's the best way of doing it? And we chewed through a few ideas, and we actually ended up bringing in the V8 engine and Node.js. And we pulled that into the runtime of the database. We used that to pre-process the JSON in a JavaScript script and then feed it straight into the table that we needed to. So as a flexible system, as a platform for that kind of thing, then yeah, there's just no shortage of stuff. One final class of things that you may hear about is, I can't remember the acronym for it, it's, there we are, foreign data wrappers. Foreign data wrappers are exactly as the name suggests. So if you have a CSV file, okay, that's a simple example, but you can load a CSV file straight from disk and you can present it via Postgres as if it was a database table. You can load an XML file straight from disk. And when I say straight from disk, I mean straight from disk. I don't mean loading it into a table, then presenting it to whatever application is using the database. I mean having it sat there on disk, building a table schema in front of it, and then issuing SQL commands against it. To give you an example of one of the ways I use that, I actually have my own VoIP system for my telephones at home. And when telephone calls come in, I have a database that matches against the official Ofcom database. The official Ofcom database of UK dialing codes is given away by Ofcom free as a series of very, very large CSV files. You're talking a few million rows in them. And I basically just download them, plonk them on disk, restart the server, jobs are good. new data in the tables. No fuss. So, that's my case. Well, that's a bit of a case for Postgres. Some of its highlights, some of the things that it's good at doing. Now, to talk to it in .NET, we have NPG-SQL. NPG-SQL is the official database driver for Postgres. And when I say it's official, I mean it is Microsoft-sponsored official, because it is actually maintained by one of the chief guys that work on the Microsoft data team for Entity Framework, along with others that he's built the team with. It's a GitHub project, like most of them. You can go and join the team if you want, if they're asking. It's all open source. You can go and look at how they've done it. It's written in C#. So because it's written in C#, it's a fully fledged .NET assembly. It will work with F#. It will work with anything that can consume a .NET assembly. And as from .NET version 8 onwards, it actually uses a number of different other things that has front ends for, such as NodeTime. Anybody heard of NodeTime? Yeah. So anybody who's come across NodeTime will know that NodeTime is the missing date time manipulation book for C#. Yeah. If you've got to do any work with time zones, dates, times, addition, subtraction, anything like that, you really should be using NodeTime. NPG-SQL has an adaptation on NuGet called NodeTime.NPG-SQL. The spatial stuff has a similar one that is NPG-SQL. I forget what the other bit. We'll come to it later. I've got notes on here for it. But these two interfaces, when they are put in with NuGet alongside the official NPG package, will give you just a whole magical world of first-class data types. So where you would use a date-time type in .NET 8 or the new date or time types on their own, they'll just magically be transformed when you use them against Postgres. JSON types, numerical types, range types, the list goes on and on and on. But I don't want to get ahead of myself. These are the people you've got to thank for NPG-SQL. So Shay here actually works alongside, forget his name. Oh, never mind, it'll come back to me later. He actually works alongside the principal engineer on the .NET Data Services team. And the other three, I actually believe this guy is a medical doctor. This guy's a juror or something like that, and I can't remember what bar is. But the four of them together make NPG-SQL what it is. In the past, I believe two of them, as well as Shay, who still works for Microsoft, have worked for Microsoft. Point is, they know Entity Framework inside and out, and NPG-SQL and the NPG-SQL Entity Framework extension actually just makes the whole thing seamless. Now, saying that, I'm not a big fan of Entity Framework, as I mentioned up front. I prefer to use Dapper. I'm a bit biased because I never really took to Entity Framework, even when it was brand new technology and it was touted as being the greatest thing since sliced bread. I've always been somebody who likes to be able to fiddle with the SQL directly. But I do love the idea of being able to take a record or a class or another object and just throw it into a database without doing any hard work. And Dapper allows me to do that. Dapper allows me to still have control over the SQL statements that I want to use. Again, you'll see this later. But it means I don't have to go this field equals this, and this value equals that, and the other, or use anything complicated like Mapster, AutoMapper, anything like that. I'm not actually following my notes here. I'm just sort of reading them and then doing an AI summary of them, by the way. So if I sound a bit disjointed, it's because I've practiced the notes, but I'm not actually reading the notes. I guess really why I don't like EF is when I first started with Microsoft Technologies, and I'm going to give my age away here a bit now, ADO.NET, DCOM, and Microsoft Foundation classes were how you wrote enterprise applications. Yep, I know that grin. I know that grin. And I've just said that about the convenience of mapping, so there we go. Okay, so we've whizzed through the first 13 slides at quite a bit of speed there. So standard data types. I mean, I'd be amiss if I didn't cover these. I know, like I said, anybody who's done entity framework will understand this stuff, but there's a couple of little caveats that I'll mention just to cover it off. All the data types that you're used to in other systems like SQL Server are all covered as first-class citizens in Postgres if you want to use them. Ints, reals, decimals, floats. In fact, Postgres has about 20 different types or 20 different ways to represent decimal and floating point notation. The only one you should be using is numeric. Well, again, I'm getting a bit ahead of myself there. In many cases, a lot of the types that you will come across actually exist as aliases. So the float type is actually an alias for numeric in the more modern versions, but it will be its own type in an older version, and this is important. Modern Postgres is considered to be version 10 onwards. So from version 10 onwards, you realistically do, for things like decimal and float, only have the numeric type. And everything else is an alias. But if you're still working against an older version like 8.4, and yes, there are still 8.4 systems out there because it was incredibly stable. You know, I know somebody who's still running a version 7 cluster, and they just don't want to change because it works. It's stable and it works, and it's the right tool for the job. So when they rewrote the kernel from version 10 onwards, a lot of this stuff was promoted to be aliases. And the basic advice was, don't use the alias, use the underlying type. You'll find this quite commonly will be in things like text. So Postgres, for example, char and varchar, and all the crazy different variations they are of char strings, just use text. Yeah, just use text. Declare the column as text. If you've got to use strings, job done. Same with timestamps. Timestamp TZ. Yeah, don't use timestamp. Use timestamp TZ. Even if you do not have to use a time zone. Why? Uses exactly the same amount of space in the database. 32 bits, I think, no, 13 bytes, something like that. And whether you use the time zone or not, it doesn't matter. It's not going to take any more or any less time. Big serial UUID. Big serial is basically an alias for long. Yeah. So if you're using 64-bit types, big serial. And be careful of bool and bit. Bool and bit are probably the most evil of the aliases. Oh, I've skipped over the serial. I'll come back to the serial bit in a minute. Bool and bit are probably the most evil. You might be used to using bit in SQL Server, yes? And SQL Server's bit type is actually a bool. It's a 0 or a 1. Postgres isn't. Postgres' version of bit is exactly that. It's a textual version of a bit. So it is a number 1. It is a character 0. It is the word true. It is the word false. Yeah? And anything that can be roughly equated to a non-standard Boolean type. So if you want an actual integer bool, use bool. Don't use bit. Serial keys. So, like I said, I'm a bit disjointed here. Big serial is a big version of the serial data type. Don't use the serial data type, use identity. Postgres now has, from version 10 onwards, identity, and it works exactly the same way as identity in SQL Server. Yeah? First number's the start, second number's the increment, something like that. Yeah, okay. Where possible, always use numeric for number types. Yeah, I've already mentioned that. But numeric works with a set of parentheses after it, which is the total number of digits you want to use for the number and how many after the decimal point. Yeah? So you can basically use numeric to make 128 byte huge values if you need to. Yeah? Don't use money, don't use float, especially not money. Do not be tempted to use money because it's old, it's flaky. The code is written in C++ that is now getting on for about 20, 25 years old. And it has lots of rounding errors in it. If you're doing financial calculations of any kind, using money will bite you. Numeric 10, or any size really, but 10 is the minimum. 0 is the equivalent to a standard int. So 10.0 is int, and the int data type is aliased to that as well. Right. Now at this point, I've got a marker in my slides that says go through the standard data C# demo. I'm going to leave the demos until I've finished the slides because that means I've got to change my monitor configuration, and that caused me a few problems last time. So I'm going to skip ahead and go back to the demos after I've gone through the slides. Yeah, because the Postgres team are so proactive, this is the link you need. So anybody wants to take a photograph of that, do so. It will save your life. And you think I'm joking about that? Honestly, the amount of times I've had strange and weird bugs in Postgres-based applications, and I've sat there for a couple of days scratching my head, and I've gone and read that and found the answer in 5 minutes is unbelievable. And they keep adding to it as well. Yeah? That list is basically a huge list of some of the points that I've just mentioned, the different aliases, the different types, things that have evolved over time. It'll always keep you right. And as well as that, it actually has a bit of humor in it as well. I'll leave that for you to find out. So that brings us on to advanced data types. Now, how many of you have seen a list like that applied against SQL Server? And that's just the tip of the iceberg. You can actually put arrays straight into a database column. And I mean proper arrays. You can take an int square bracket syntax in C#, plonk a load of numbers into it, and go, write it to this column, please. And it'll write it to the column. And not only can you read and write that column, you can filter on certain values within that array, you can look for patterns in that array, you can do mathematics on that array, you can select from this array and that array and join them together into another array column. Literally, the types of things that you would do in a first-class language like C#, you can do with basic SQL statements on the array type. HStore is another one, it's very similar to the array type. In some ways, HStore was the first custom data type for Postgres prior to the 8.4 branch. HStore's not really used anymore these days, but it's left for historic purposes for those few people who do still use it. What the Postgres team do tend to do is if there are still big groups or big groups of people using specific features, is they will leave them in or they'll find a way to alias them properly. They're not big fans of saying, right, nobody uses it anymore, let's throw it out and make everybody crap themselves and have to rewrite everything. JSON, JSON-B, hands up. Who knows the difference between JSON and JSON-B? No one? So JSON, as you all know, is JavaScript object notation. JSON-B is a binary format of that. Now, typically, we don't read and write JSON in a binary format. But anybody who's ever done any work with things like credit and debit cards or serial data streams, you'll be familiar with things like APDUs, BERTLV structures, things like that. Binary JSON is very much like that. Everything is boiled down to opcodes and descriptors and such like, if you were processing it directly. The advantage of JSON-B over JSON is you're not using standard text practices to manipulate it. So, for example, if you were looking for a field in the JSON object called age, you don't have to start at the beginning and go scan, 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 have I found the word age yet? A la normal string processing. Instead, the JSON-B would have some kind of a binary marker that allows you to just say, right, I want the age field and the value of it, poof, there you go, job done. And it will return it not as a text version of that value, as JSON would, but it will actually return it as an int or a float or a money or whatever type it's been set to. What that means from a Postgres point of view is if you can, you use JSON-B, because JSON-B has many more operators, many more things that it can do in the database, much more APIs that can manipulate it faster and more economically, I think. Word, maybe not the best description. Box, line, points, yeah? 2D drawing. Yes, people have written CAD packages using Postgres. It may just be a set of 4 points that defines a box. It may just be 2 points that defines a line. It may just be a point. But there are API calls that allow you to say, is that point inside that box? Is that box higher than that box in 3D space? So if you are processing, say, a 3D model, you can actually do things like sort the view planes. Yeah? Anybody who's done games programming will know things like camera depth and sorting polygons in front of other polygons. You can do all that stuff using the geometric data types. INET CIDR. Anybody know what CIDR is? I take it we've got no network engineers in the room then. Yeah? CIDR is basically where you have an IP address. We all know what an IP address is. And you have the slash on the end and the size of the bit mask. Or is it the slash and the full notation? I think it's the full notation, isn't it, for CIDR? I can never remember. It's one of the two anyway. But what this basically allows you to do is to take this fully expressive internet address notation, plonk it into a database, and then just say Postgres. See all those IP addresses you've got in that table, tell me which ones belong to this netmask. And it'll go, yeah, sure, there you go, boom. No problem. Index it properly, search it properly, all that kind of stuff. It will do the heavy lifting for you. Ranges. I love ranges. Ranges are fantastic data types. Yeah? Think about a hotel booking system, right? So we've got 10 rooms. Obviously, you can only have one party in each room at a time. And people come and they book them for dates and times and things like that. How easy do you think it probably is to write code that allows you to pick a room twice if you're not careful at watching your date and your time reservations? Yeah? Quite easy if you're not watching how you're validating things, if you're not looking at your code properly. With the range type in Postgres, it stops you from doing that. You basically say, that is a range, this room is booked for that range. You can put exception handlers and data type filters on the column so that if you then try to write a date or time range, and this can be inclusive, exclusive, or unboarded, if you then try to write a range that matches something that's already in the database, it won't even let you write it to the database. It will say, no, you've already got that room booked for that time, go away. It handles that for you. MAC address, much the same as CIDRs. You can do all sorts of weird and wonderful calculations on it. You can take the 6 octets, break them out. You can put it against a lookup table, so you can match the first 3 octets against manufacturers and find manufacturer ranges and used ranges. I use this, I've written myself a little management thing for the virtualization server that I have. I have a Hyper-V server, and it's a nightmare figuring out which MAC addresses are which, because I have my system set up so that a MAC address gets a different IP address from a different DHCP pool. So I need to know which MAC addresses are on which of my Hyper-V servers and what IP range I should be allocating them in. Postgres does all that for me. All I basically have to say is, which cluster is that VM on? And it'll come back and tell me. Polygons, much like box, line, and points. There is no restriction. It can be a 2 million-sided polygon. It can be a 3-sided polygon, aka a triangle. Yeah, 4-sided polygon is a box, obviously, but other than that, absolutely no restriction. And you can do all sorts of geometric functions on them: radiuses, intersections, radians to other conversions, you know, things like that, Cartesian coordinates, all sorts of stuff. Geography. Geography was the original geography type built into Postgres, but I'll show you something a little bit better a little bit later on, because since the geography, there was the spatial types added in the form of PostGIS. And of course, PostGIS, we have different EPSG codes, geographic points, geographic lines, geographic polys. Yeah? And all of them, the different spatial coordinate systems are all fully respected with them. That just covers the demo that I'm going to do in a bit. And finally, well, maybe not finally, slide 21, 25. So this probably is my final topic that I wanted to largely cover, is pub/sub messaging. So how many of you here are looking after products that use Redis? Quite a few. You don't need Redis. Postgres can do it for you. There's actually a plugin for Postgres that makes its pub/sub system be Redis compatible. I kid you not. You can make that be a Redis server. That's how simple it is to listen for notifications. 1, 2, 3, 4, 5, 6, 8 lines. Now, obviously, that is just a little command line thing. You obviously wouldn't do this in a production application, but that loop will sit quite happily and run in a background process. We know we know the background tasks in the ASP.NET these days. Yeah, that will run wonderfully in a background task. And these notifications don't have to come from your application either. You'll see this in a minute. Right, so that bottom link, the codeguru.com, that's an article that I wrote when I used to run the C# column for Code Guru a lot of years ago now. That is basically using an older version of NPG-SQL, and it runs on .NET Framework 4.8. And that was actually used to do a full Office enterprise application series of desktop applications, not web applications, actual desktop applications running on each of the workstations that subscribed to different channels and received information coming in from a central telephone exchange as to which telephone lines were busy, not busy, who was doing what numbers were being processed, that kind of thing. It's a good example of how that kind of stuff could be used for enterprise. And that is the end of my slides. So we'll jump to the samples. But there you go. If you want to take a photograph of that one, that's how you can come and harass me. Please don't harass me though. I'm a good guy, really. I'll go back and I'll do the summary in a minute. We all good with that one? And there's some more links for you. Yep. Okay. So now I'm going to switch my screen setup back to a mirrored setup. Please don't mock me for the messy desktop. It's just I'm absolutely terrible at looking at something on this and looking over my shoulder trying to drive stuff. Okay, so and ADO.NET, how familiar is everybody with ADO.NET? Yes, no, general feel? Yeah, I know you are. You're a dinosaur like me, Peter. Right, well, ADO.NET is not as complicated as it might seem to be. I mean, you can see there that I'm defining my actual operations as strings. Now, you are going to see some potentially bad practices in these demos because I just chucked them together quickly. They are just that, the demos, but they illustrate a point. Did I go too fast there? Yes, I did. So, connection string is dead simple. Host, username, password, database. Right? A Postgres server can hold multiple databases, just like an MS SQL server can. Obviously, your host is the physical machine that it's on. Username and password is the minimum you need. There are other things that you can add to the connection string. Most of the time, you don't actually need them. If you are curious as to what they are, everything is documented at npg-sql.org. Then you just use NPG-SQL data source.create, you give it the connection string, and it does the rest of the magic for you. Unlike older versions of ADO.NET, you don't have to create the connection, then the connection string, then pass the string, then get a builder, and goodness knows what else. It's all literally done in them first 2 lines. That is your connection, and it's set up, and it's working by that point. So, standard read loop. You get your data source, you create a command from your data source, from your SQL string above, you await, execute the reader, and then you just await reading. And that will keep going until it returns null. As soon as your reader returns null, you've got no more rows left to read. So you don't need to worry about keeping count or anything like that. You just go read, 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 oh, no more. Job done. Now, yes, I'm not going to sit and go through all of them like that. Even I'm not that much of a masochist. And that's it. Dead simple. Just to prove that it worked, there you go. That's the 3 rows that were in the test database. And if there is any doubt, I should actually have opened this before I started. I apologise. But this, by the way, if you have to manage a Postgres cluster, that's the tool you want. That is the official tool from the people that make Postgres. There are other tools that will talk to it. dbeaver, the JetBrains tools are particularly good. DataGrip will talk to it. Most other multi-platform database tools will talk to it. But pgadmin is by far the easiest and the one that actually just helps you. You know, I've tried umpteen different things over the years, and I always end up going back to pgadmin. Always. But enough talking. No, you need to type in there, don't you? Right, where are we? So that's the standard data one I'm doing, isn't it? So if we dump all the rows in there, there you go. You can see there's the 3 rows that appeared on our console. Not that anybody was probably in any doubt, but there we go. Inserting, dead easy. Parameters, add with value, add with value, add with value. Yes, I know you shouldn't really be using add with value. There will be some people in there that it will, in this audience, that it will itch their brain. I know fine well, because it itches my brain a bit. But that is the quickest way to add parameters, and you're not doing string concatenation. It's fairly safe. It's a reasonably good protection against SQL injection. It's not by any means perfect. There are places it can go wrong, but it's better than taking a string and concatenating using pluses and whatever. And then, bam, query's executed. Again, the SQL's above in a string. That's your job done. If we go back to pgadmin and rerun that, there you go. You can see it's added the row to the end of it. Again, it's not rocket science. It's all dead simple. Same with an update. Update is very much the same as doing an insert. And delete is even simpler. The reason I'm adding a parameter there for the delete is because I'm using that in a where statement to filter on. So I only remove the row that I want to remove. If I did that without any filtering, then would have just emptied the database for me. And then the Dapper approach. Again, I'm not going to spend a heap of time on this. There we go. Again, it's the same kind of loop, only this time you can see that I'm reading it as a record. So I have this data type, this standard data type here, which, as you can see, mirrors the actual structure of the table. And Dapper will just magically map that to each row as it pulls it out. I don't need to bring things out, put things in one field at a time. Update, delete, all the same. I'm not going to continue with that because I think that's all fairly straightforward stuff. So, advanced data, set that startup project, and run that one. Right, so I'm going to treat the JSON one separately. I'll explain that one in a moment. But as I said with arrays, so the first one there is, you can see select int array from advanced data. So it's selecting just the integer array column. If we go back and we look at that in here, there you can see the first column is that integer thing, and you can see the actual specification of the column looks the same way as the array syntax in most of the languages. Same with your text. That's basically a string array. Your JSON and your JSONB. You can see JSON and JSONB fundamentally look exactly the same when you display them in the database or in your database tooling. But underneath, you've got the JSON versus JSON binary. And then we've got a date range val there. Now, looking at my code, I actually haven't got anything in that uses that for some strange reason. I don't know why, but as I was saying before, with ranges, you can see you've got the first part of your range there, you've got the second part of your range there. Square brackets denote that everything's inclusive. So it will be that value and that value are included, as is every value in between. The alternative is a curved bracket on the end. So a curved bracket means that the value at that side is not included. So curved bracket there would mean not that value, but anything after it up to that value. And if you've got several ranges in the column, you can sort and filter on them. You can say, does this range overlap with that? By how many minutes does it overlap? Or by how much of a value does it overlap? How many decimal places does it overlap? If it's geometry or geography, how many pixels does it overlap? The possibilities are endless, basically. And you can see that the code for that, again, is very simple. Right there. Give me that value, drop it straight into an array. No conversion, no having to go through it one at a time and put it into the array yourself. It's done. And to show that point, there's the values from it. Manipulating the integer array, pick a new random number, stick it in, and then just write that array back to the database. And if we go back and look at this, there you go, you can see that that middle number's changed from 77 to 84. Without rewriting the column, without rewriting the whole field, it's updated just that value in the array. Just on a side note, if you're writing shopping catalogues and you've got tags like colours and dress sizes and things like that, this is absolutely just the best thing for doing that. You know, Stack Overflow, you know the tags that you have under questions in Stack Overflow, things like that. It is just brilliant for that kind of use case. List string, it's much the same thing. So we'll not waste any time with that. Yep. Again, add, insert, everything. You can see it's all SQL statements. Again, as I mentioned at the beginning of the session, because I like control over the SQL. Yeah? It's not hidden from you, but you still get the advantages that you would get from using Entity Framework. And then the last one in that file, you can see there, that is an actual .NET IP address type. So all of the stuff that .NET can do with that IP address is just doable. You don't have to convert it from a string to an IP address or anything like that. You literally yank it out of the database. It's an IP address as it comes out of the database. Then you do whatever you need to. So configuration for an application, for example, what port it's got to listen to, what IP address your API server's at, that kind of thing. Yank it out, listen on that port. Job done. And that's that bit. Now, the only thing that you have to do slightly differently is with JSON. And that's not because there is a problem with the way the JSON stuff works. It's because the NPG-SQL team haven't updated the data provider to work in the newer way yet. So you can see here, instead of having that nice little one line where we take the connection string and rack up a connection and have it work, you've got this 2-line longer thing. Yeah. Now that matters to some people. I know, because I've actually had people complain at me and say, well, that can be 2 lines less. And it's, well, personally, I don't give a damn. Code's code. It compiles, it works. But people do get their knickers in a twist over that kind of thing. This has to be done this way because on the data source builder, we're enabling dynamic JSON. And you need to enable dynamic JSON if you want to manipulate JSON using Dapper. Right? That's the only reason you do that. If you're not using Dapper and you're just using ADO.NET, jobs are good. Other than that, you can see the code, dead simple, select, update, set. It really doesn't give a damn. And I can use an array syntax similar to the new array syntax that's in C#, the hyphen with the arrowhead for, I forget what it's for now, for like lambdas and that. It is a similar sort of syntax for Postgres, where I've got that select JSON from advanced. I could have where JSON value array age equals whatever, just to select people who had an age of 31. I can actually drill directly down into the JSON, sort, filter, index, everything, just as though it was a first-class RDBMS column. I'm getting harangued by Kasim here, so I'll just scroll past that bit slowly enough, hopefully, so you can see that the well, you can see there that the Dapper version again is very simple. Pub sub. So I will just quickly set that as a startup project, and we'll go 5. So all this does, it's that piece of code that was in the slide. It sits there and it listens to this channel called QDOS demo, sets up a lambda to listen to it, while true, and then it just sits and does that. That's it. Nothing more. But if I go to here, And of course it's not going to, is it? Because I'm not actually on a database. We go. Query tool. If I go notify QDOS demo hello Hayloft. Take that off the end of there. No, what did I do wrong? Oh. Hey? Yeah, don't think you need the hyphens. I was doing this before I came out as well, you know. Oh, sorry. Anyway, if I got the syntax right there and I wasn't trying to rush it, what would have happened is that would have popped up a line under there in the application and the string that I passed to it would have appeared on it. So that is an actual disconnected pub sub channel. That notify command could have been sent from any other application, written in any other language on any other system, into that database. With that channel notifier, this would have picked it up. It's used quite a lot for things like PG Bouncer. You can actually set a Postgres database up so that one database will back another one up across an entire continent. It's insane, some of the backup strategies that this does. Right, one more minute. So the last thing I want to show you, and this will be extremely quick, and that is spatial data. Now, that as it stands, if I run this, and of course it's not, because it's still pointing at my live server at home, isn't it? Right, I'm not going to run that, I'll just quickly talk through the code. So what we're doing here is we're using a toolkit for .NET Desktop called Gmaps, Great Maps, not Google Maps, Great Maps. If you've got to do any kind of mapping work in a desktop application, Gmaps is the toolkit to use. Fantastic piece of kit. We use an OpenStreetMap. Everybody knows what OpenStreetMap is. We're setting the center of it to these two coordinates here. And anybody who's ever looked at a GPS device will recognize these as being GPS coordinates, because one number's a minus, the other one's a fairly large number. Those are known as lat-long coordinates. Now, typically in a database like Postgres, your data, which I can't actually show you because this won't run, will come through as a set of coordinates that are specific to the area it's being used in. So if you're using map data in the UK, the highly likelihood of you purchasing that data from the Ordnance Survey is that it's going to be in something called OSGB 36, which is stupidly long numbers that don't map very nice to these nice WGS84 numbers. If this had been running, what I would have showed you is I would have read the polygon, I would have showed you that it was OSGB 36, I would have then showed you the lunacy of trying to convert them myself with my own maths in the code, and then simply I would have just gone down to the load function. That's the points. I would have just gone down to the load function here, and I would have swapped that string for that string and let Postgres do the work for me. This ST transform thing here will transform to ESPG 4326. For those who are not GIS geeks, EPSG 4326 is WGS84. EPSG 27700 is OSGB 36. So if I was going from that back to the other, I would replace that with 27700 and it would convert whatever data I'd given it back to the UK standard spatial. And would have done the job for me. I wouldn't have had to do anything in code. I wouldn't have had to do anything with the spatial toolkit that I'm using except draw the map, and would have handled it for me. And lastly, I'm sure you saw me scroll past that nice meaty SQL statement there. This basically takes my points table and it takes the outline, because if this program was running, what you would see is a map, and I've drawn a border around this location, and I've scattered a load of random points across Newcastle city centre, and then I would have told it to give me just the points that fall inside the boundary that I've made for haylofts. And that's exactly what this does. Again, I'm asking Postgres to do the heavy lifting for me. I've basically said, this is your polygon. That's the area around the haylofts. I want you to go through every point in my point table. And this is every point in the point table. So that could be 10 points, 20 points, 20 million points. Yeah, it'll go through, if it's properly indexed, it will do it in like that, with proper spatial searches, proper spatial lookups. Then I want you to give those points back to me. I want you to transform them to WGS84, and then I only want you to give me the ones that ST within fall within that geometry there. All in one SQL statement. And I think it was you that asked me last time, why Postgres and why not just normal numerical values in something like SQL Server? Well, part of the reason are these EPSG codes. Yeah, it's all right saying I can put 40, 45 point whatever and -1 as columns, but can you guarantee that your data entry is pure enough to always get legitimate latitude, longitude coordinates in? And then there's the whole thing, if you're handling rasters and even some vector data. I've got map sets in my GIS server at home where one single map at a 1 in 10,000 scale is about 25 gigabytes worth of data. Yeah, I tried doing that once with SQL Server. I will not repeat that experiment again. And that's the examples. You've already seen the slides, so feel free to boo me off now. There you go.